right. Hello, everyone, and thank you for joining us today for our webinar on how to choose the right hoist for your application. Chain hoist versus a wire rope hoist. You'll learn the difference in duty cycles and how to select the right hoist for your application. My name is Gisela Clark. I'm the social media specialist at Columbus McKinnon, and I'll be your host for today's webinar. Presenting today will be Peter, our training manager specializing in rigging and load securement. Peter has dedicated 15 years or more to Columbus McKinnon as an engineer, designing engineered lifts, slings, and forgings. He's traveled throughout the world teaching proper rigging techniques, rigging gear inspection, and hoisting crane inspection and maintenance. We'll be recording the session today, and the recording link will be added to our YouTube channel. Everyone in attendance will receive a link to the recording. Even those who registered and couldn't attend will also receive a link in case some of your colleagues couldn't make it. We have everyone in listen-only mode, so we encourage everyone to ask questions in the Q&A pane on the bottom right-hand side of your page. We'll take 5 minutes at the end to answer them. If you'd like to ask them throughout when it hits you, I'd be glad to try to take it during the session myself. So thank you for your attention, and now I will turn the meeting over to Peter so we can begin.
Okay, and happy Halloween, everybody, and thank you for attending today's webinar. Today we're going to talk about choosing the right hoist. Within that, we're going to talk about duty cycles, the electrical hoist portfolio, types of suspensions, and questions. So really what we want to do is just kind of go through the basics of what you should be gathering, information you should be gathering, to be sure the correct hoist is applied for the right application, and that we do not have a misapplied hoist. Which could lead, to production issues, things of that, if a hoist isn't meant for a certain application. So we'll start at the basic level. What is a hoist? It's a machine used for lifting and lowering heavy loads, powered by hand, electric, air, and available in various configurations, suspended from a hook to an attachment point. Suspension types, you can also have hook to lug, clamps, trolleys, hoist rings, links. So it's important that we know how we're going to size this up or how we're going to suspend it. So the parameters you really need to consider is obviously we need to know the weight of the load and any tooling we're going to lift with the hoist, the physical size of the load, headrooms and obstacles, what our total lift is going to be, how high do we need to lift that load, how far does that hoist need to reach, so from ceiling or where it attaches to down to the load, that's what's called the reach, is how far do we need to get down to attach the load, and then gets confused with lift once in a while. Lift is how high we're actually going to lift that load, which doesn't mean we're going to lift it all the way up to the ceiling necessarily. We only might need to lift something 2 feet, but actually have 20 feet of reach. So two are drastically different. The type of operation it's going to be involved in, location of an operator, how are they going to be able to operate it? Are they fairly close to the hoist, or they need to be a ways away? The frequency of the use, the type of suspension, the accuracy of load placement, how critical is it that things get spotted real precisely, so that's going to affect speeds and how we size that hoist up. The power requirements, very important. What voltage are you going to supply for it? Single phase, 3-phase, and the voltage requirements for that hoist. And then the type of hoist controls, and that also go along with where the operator is located. Do we need a pendant or a radio remote? So those are everything we want to make sure we get all that information. If we get all that information up front, we should be in fairly good shape to be sure that we size the right hoist for the application. So let's get into duty cycles and talk about duty cycles of a hoist. And so we want to know how many starts per hour. So if we can gather, sometimes this information is tough to gather, but it's a number of hoist motor starts per hour. The hoist operating time, how long is it going to be on per hour? That's expressed over a period of work. And I'm going to go into some examples of that. So if that doesn't quite make sense, it will by the end of this presentation. So here listed is the duty cycles produced by the Hoist Manufacturers Institute. And you can see H1 through H5. Columbus McKinnon hoists are rated at electric hoists are rated at an H4. And that's for high volume handling of heavy loads, frequently near the rated load, total running time of not over 50% of the work period. So the operational time at an H4 duty cycle is 30 minutes per hour, or 30 minutes on time, when that hoist is lifting 65% of its rated load. okay? And that's not 30 minutes continuous. It's 1 minute on, 1 minute off, okay? The other side of that is the number of starts. You can press the on button or up or down button 300 times per hour. Now that seems like a lot, and it is, but in some circumstances in a misapplied hoist where maybe the speed of the hoist is too fast, and so that we need to be more precise in positioning the load. So what happens is the operator starts jogging the hoist, or just he's basically mashing the button down many times, and we can easily exceed that 300 by doing that, and therefore we'll heat up internal components of that hoist, and we can result in one of the components possibly failing in the hoist by exceeding that duty cycle. So we want to be sure we don't do that, and that we don't misapply a hoist. So we want to get the correct speeds in place, or maybe we need 2 speeds, maybe we need variable frequency drives where we can make it go to a crawl and then speed it up when we need to. But ours are, excuse me, right around the H4 duty cycle. That's where we are for the majority of our hoists. So we're going to talk about electric chain hoist and the wire rope hoist. So here's a typical example of electric chain hoist. The upper suspension could be hook, could be lug, depending on how we're going to mount it. Usually has a chain container so that we don't want all the chain kind of laying all over the place where it interferes with lifting the load or interferes with the operation. So we tend to put the loose chain in a bag while we're operating the unit. It has a control cord if we're going to go with a pendant station. And if you wanted radio remote, a transmitter would be mounted to the hoist. And then you would get a radio remote control for it as well. And then you have your lower suspension, and typically a hook, or we can have a latch lock style hook, and maybe you need something special there, or some type of special tooling to go along with that hoist to help lift your load. Quickly, the CM portfolio of all the various electric chain hoists that we sell. The Lodestar, the CM Manguard, the Shopstar, Value Star, the Coughing JLC, the Coughing EC, the EMC unit, and the budget. And within our hoist calendar portfolio, we'll give you all the speeds, the capacities, type of suspensions, and where they can be and where those hoists can be applied. So that's something that the Columbus McKinnon family of team members can help you out with. And we'll be doing more and more webinars and more stuff on applications as the months go on. Here's a typical wire rope hoist. This is the CM Global hoist. The big difference between the chain and the wire rope hoist is you got a very large frame, and wire rope must be wound on a drum and can't overlap on itself. So therefore, the wire rope hoists tend to get a little bit larger. So you're going to have a large frame, and on one side is going to be your gearing and rope drum. On the other side is going to be your electric controls. So generally, they're a larger type of unit, and usually more towards higher capacities where we see wire rope. And so there you're going to see the anatomy of the external anatomy of a wire rope hoist. Quickly, the wire rope hoist that we offer is the Yale Global King hoist, the Shaw Box 700 series, the Yale Cable King, the Y80 or the Shaw Box 800, and the Yale Load King high capacity unit. So kind of the portfolio that we offer in the wire rope family. And then we have air hoists. And why an air hoist? Why would I not want to go with electrics in this case? And we'll just briefly discuss an air hoist. It's used for frequent, faster, and longer lifting, and where electrics would exceed a duty cycle. So if I have an instance where maybe I do have to start it over 300 times, or maybe I am going to use it well over that 30 minutes per hour, I have a high production. We see this a lot in automotive plants. So therefore, automotive tends to go with a lot of air hoists. They have good air supply systems since they're using tooling to work on their assembly line. And so the air hoists are prevalent in that industry. They're ideal for heavy usage in environments where electrical hoists are impractical. Yes?
I'm sorry. I just had a quick question. What would you consider an impractical environment?
Places like where there could be flammable gases or fumes like paint lines, or maybe they're working with a fuel mixture, anywhere that you want to have some more type of spark-resistant type features. We do offer spark-resistant features in the wire rope and the electric hoist, but in this case, it's even better than one step further where you're going with an air system, so you're eliminating that electrical spark altogether. And so in that case, it's more practical to use an air hoist. But you do require additional equipment, you need to have a compressor and
Right.
to supply that air hoist, the proper size compressor and equipment to make those air hoists run efficiently.
Right. Okay. Thanks.
Very good question, though. Thank you. And there, quickly, the extra loaded air hoist. It pretty much, if you looks like an electrical hoist. And in some of our electrical hoists, we do convert to air hoist, so they would look almost the same, except there's an air motor at the end. So we have air supply lines, but it is a chain hoist, and it has its unique applications where you want to use it. The nice thing about air, we can get a lot faster speed. Some would go up to 65 feet per minute, so some extremely long, fast speeds. And we have the Air Star, the Shop Air, the Air Star 6, and the Chester SLA units. And again, we can convert some of the wire rope and the electric hoist to air if there's a certain model that you would need and say, well, I really want that model fits, but we really would like that in air. Our engineering would take a look at that for you, and we probably may have done it already or see if it's applicable. Once we decide electric or air, and what type of hoist, we need to know the type of suspension. How are we going to suspend it? What do we need to do? What are we doing with it? And how are we going to suspend it? Is it going to be just over one specific area? We don't need to traverse it at all. We just need to go up and down. Then a beam clamp would suffice. So we just need to measure the flange width, and we would just size a beam clamp accordingly with the right capacity and attach a beam clamp. Or do we need a trolley? We have push, geared, motorized. If we're going to be traveling a long length, we probably want to go with a motorized trolley. If it's something where maybe like on a jib and it's a heavier type load, maybe we want to go with a geared trolley where we can just traverse the load with gears, but we're not going a very far distance. And then we have push type trolleys where it's a manual where you kind of pull on the load with ropes or pull on the chain to get the trolley to start moving. So it's, we just got slight movements for push or manual type trolleys. So it moves the hoist and it's loaded horizontally, and there are available load headroom models or tight radius models, but you're going to have to get the correct suspension for that hoist, or make sure if you have a hook mount that it's going to fit in the right trolley. So you want to ask those types of questions, to size up your trolley, or maybe get a lug mount. So that it may require a special suspension to get it in the right trolley that you need. So the various trolley options that we offer, we have the CMCO adjustable trolley. Now, if you ever assemble a trolley, they're tough to do sometimes. They require spacers, and you're up in the air, and you need an extra set of hands to help you get that put together. Well, this unit is similar to like the beam clamp. You just like a vise, you just kind of crank it on your flange, and it's a very easy assembly. So it's a really nice trolley that we offer that's for ease of use, ease of assembly. We talked about the beam clamps already. We have the CM632 close radius trolley, the Coffin CPT trolley, the CM Universal trolley, which is new for us. If you're looking for very low headroom, that's the trolley you want. The hoist pretty much bottoms right out on the bottom of that trolley, and you really get some nice tight headroom with that trolley, so that's nice. You can see the hand-geared type trolley. That Universal trolley also has a version of a hand-geared type. And then motorized versions, and the Coffin MT motorized trolley. So depending on what you need and what you're looking for, we probably have a trolley that will work for that situation.
So Peter, you said the CBT trolley was the one for low headroom?
The CM Universal.
CM Universal, okay.
Yeah, that's our newest trolley, and that hoist, I should probably get some pictures, some side-by-sides with other trolleys. You save 6 inches or greater in some cases.
Okay.
So that might mean a lot to somebody. Some people, I don't need a low headroom situation, and others, yeah, I need every inch I can get depending on the load configuration and how high I need to lift stuff.
So the Universal will be the trolley of choice for that.
Yeah, it's a really nice trolley. It's one of our newest ones, and then it works for any of our hoist line if you get the right adapter put on the hoist to work with that trolley.
Thanks.
And then you can see on the wire rope line where usually on the wire rope hoist, the trolley is incorporated with that wire rope hoist. So you can see it's a combination, sort of like the Yale Global. You can see the trolley and the hoist are all one unit. So you would just need to know the flange, the beam size that you're going to put it on, or the bridge that you're going to be putting that on, to be sure that it can be sized properly for that application. So choosing the right trolley, again, obtain the following information. You want to know what the beam shape is. Is it an S or W section, patent track, or is it fabricated? The beam depth and height to be sure the wheels are going to fit in there. The flange width, the flange thickness, and if there's a curve radius, what that curve is, you'll see on trolley charts it'll say the minimum curve radius you can have, and that's what for a curved track. You want to be sure that that trolley can navigate that curve. So you don't want to get jammed up in the middle of that curve, so you make sure you're sized properly for that. And here, just kind of a chart where some of these apply and where they would work better. Obviously, all general use, you see them all checked off. High duty cycles, we're going to go with electric or air hoist, and it extremely exceeds that. Again, that H4 rating, we're probably going to end up with an air hoist, or have to do something special with the electric hoist. Production type lifts, electric and air, machine shops. You're going to generally see the hand lever or electric. Hazardous locations, we talked about that. It's going to be air, variable speed control, electric. Now, I could probably check air on that variable speed control because you can feather out that air. So what you're really not getting, it's really not a VFD. You're just letting a certain amount of air in and out so you can slow the air down and slow the hoist up. So you can get some variable speed control with air. And then mining, farming, construction, marine, where you would see a hand chain or a lever hoist more predominant in those types of industries. So why a chain hoist versus a wire rope hoist? So we talk about electric and air and things of that nature and the anatomy of each, but when do I go from electric? Sometimes it's more features and benefits because we do have the same capacities in both. But when we start to get really above 5 tons, we tend to start getting into the wire rope line, or where we need faster lifts. The wire rope hoists tend to get better speeds than chain hoist because, especially in the higher capacities, the chain hoist, when we get in the higher capacities, we have multiple reevings, so it really slows down the electrical hoist because we have to overhaul all that chain, and so the wire rope hoist will start exceeding the speeds of chain hoist in certain applications. But chain hoists, they're a little easier to maintain, a little bit more portability, and they're a little bit more compact, so therefore you're going to get a better end approach or better work area. So for instance, if you think of a square box, you could apply your trolley and your hoist. The smaller the unit, the more you can get towards the wall, the more work area, the more places you can place things and also pick them up with the hoist, where the wire rope hoists tend to be larger, and so you may lose a little bit of that wall space or work area depending on how close you can get to the wall, so you're going to lose a little bit of work area with the wire rope. So kind of pros and cons that I'm going over for you. Longer lifts tend to be with the wire rope hoist, and wire rope hoists are more configurable. I mean, we have platform hoists such as the Cable King, where pretty much if whatever you need done with that hoist, they can probably do with that Cable King or a platform that's built from scratch. So we can build one of a kinds or a specialty type hoist what you need. Probably if you think you need something, we probably have done it already, and so that'll be available to you. Chain hoists tend to be what's called a true vertical lift, meaning from the point I start where I lift my load to where I raise it all the way up, it's going to be in the same position. Wire rope, true vertical lift is available, but typically you're going to see as the rope winds on the drum, that the hook also moves with the rope winding on the drum, so you may not be at the same place where when you lift and as you raise the load, and that's what I mean by true vertical lift. But a wire rope hoist can be configured that way, but it's more. The chain hoist obviously is always going to be a true vertical lift.
Peter, if you don't mind, I'd like to go ahead and launch a polling slide.
Absolutely.
Great. How long can an H4 duty hoist run in 1 hour when lifting 65% of its rated load? Sorry about that typo. How long can an H4 duty hoist run in 1 hour when lifting 65% of its rated load? Would you say 60 minutes? 30 minutes, 15 minutes, or 5 minutes? Please go ahead and vote. And if you have an iPad, you won't be able to. The functionality doesn't work on an iPad, but you can shoot me your answer via the Q&A pane. That would be great. All right, it looks like it's between 3. It's between the 60-minute, 30-minute, and 15 minutes. But the majority is voting for 30 minutes. So 78% of you think 30 minutes. 12 think 60 minutes, and 8 think 15 minutes. Peter, can you go ahead and give us the answer, please?
Yep, the answer is going to be 30 minutes. So that HMI duty rating of H4 is that hoist can run 30 minutes in the hour when lifting 65% of its rated load. And again, that's not 30 minutes continuous. That's the equivalent of 1 minute on, 1 minute off. And you never really see a hoist running 30 minutes straight anyway. It's you do your lift, do what you got to do, set it back down. So yep, it's 30 minutes within that hour at 65% of its rated load. Again, air hoist wouldn't apply. That's when we would go if we exceed that definition of an H4, we need something that exceeds that. We may consider an air hoist for our lift because we obviously don't have heat generation, which is why what that is. We're generating heat from the electricity in the movement, and so air hoists obviously are not going to get as hot, so we can exceed that H4. So they really don't have that H4 rating. It's a continuous. We call it continuous duty on an air hoist.
Well, thank you everyone for answering the question and your participation. Go ahead, Peter. Thank you.
Okay, so let's give you a quick rundown and let's see if this is let's just give an application here and see what hoist we'd size up for this. So we're lifting a load of rough stock into a machining center and removing the finished part at the end of the machining cycle. The maximum load that the customer or end user tells us is 9,450 pounds, and they're doing about 1 cycle per hour. They tell us their typical load, that's their heaviest load was 9,450, but their typical load they're going to see is 5,532 pounds. They have a load, the load height is about 6 feet. The machine bed height is 4 feet from the finished floor. And they have a monorail, which is a single beam or above the workstation, and it's 18 feet from the finished floor. And they tell us the size of it. It's a W18 by 71 pounds. And that flange width, on that one we can look at steel charts or go physically measure that. That flange width then would equal 7 5/8 inches. So what's a cycle? They do one cycle per hour. Well, a cycle is they pick up the rough stock from the pallet. That's one movement. Then they move to the machine and lower it into the machine bed. Move the empty hook out of the way, right? Because we can't have that hook in our way. We got to do some machining. Then when the machine cycle is complete, they lower the empty hook, pick up the finished part, and then return it back to the pallet. And they repeat this 10 times per hour in 2 8-hour shifts daily. And they want a motorized trolley to go along with this to do the traversing action to get over from their pallet to the machine. Okay, so they told us the typical average load, 5,532 pounds. And so we are going to divide by our mean effective load factor, and there's that 65%, right? So we talked about the H4 duty cycle. So H4 duty cycle says I can have 300 starts within the hour or 30 minutes at 65% of the hoist. I can run within 30 minutes at 65% of rated load. Obviously, if I'm lifting at 70 or 80% of that rated load of the hoist capacity, then I'm not going to get 30 minutes out. I'm going to get something less. Maybe I'm going to get like 20 or 15 minutes of use per hour out of it. Or if I'm lifting lighter loads, then I'm actually going to go longer than 30 minutes. So what we do is we take that typical average load and divide it by 0.65% because we want to be sure we don't ever exceed the duty cycle of that hoist. So in this case, the minimum hoist capacity given the average typical load would be 8,511 pounds. They already told us the maximum load was 9,450 pounds, so the hoist capacity that we would size would be the larger of the two numbers or whatever that ends up being. So in this case, we would need to size up a 5-ton hoist. But what would happen if they told us their average load was 9,000 pounds, right? And then we would be even higher. So at some times when you do this, you think, well, yeah, that's the hoist I would have sized anyway before you started. Well, there are instances where the average typical load divided by that mean effective load factor exceeds the maximum load lift, where that 1 or 2 times load lift that you do your maximum load with the hoist exceeds that. So you may have to have a hoist size higher than the 5-ton. And so that's what happens when we talk about a misapplied hoist, that, wow, we should have had a little bit bigger hoist, or giving your average typical loads that you're seeing, so you're exceeding those duty cycles. Okay. So in terms of the load hook, it includes, so also remember, it's not just the weight of load, it includes the weight of the load to be lifted plus any lifting devices. If the minimum load to be lifted or lowered is more than 20% of the operating time, divided by 65% to determine the hoist capacity. They also told us floor to underside of the monorail is 18 feet. So the total lift required equals the reach minus the headroom. So the total hook travel equals load height plus obstruction height plus clearance. So they told us our load height was 6 foot. They said they had a 4-foot obstruction, and we want to be able to clear it by at least a foot, right? Because we don't want to run into that obstruction because that could be very dangerous for the operator. So we need a total hook travel of 11 feet. So the maximum hoist headroom that we can have, in this case, the 18 foot minus 11 foot equals 7 foot, right? So we have 7 foot of headroom available to us. So that means by the time we put our trolley on there and the time we attach our hoist and whatever suspension we have from the trolley, we can't exceed 7 foot. So when that hook is up at its upmost position, the saddle of the lower hook is up at its topmost position, and from the underside of the beam where we're attaching to cannot exceed 7 foot. So 7 foot's pretty big, but then you got to consider like rigging and things of that nature. We may have chain slings involved, so all that's got to be considered. And so there you start, that 7 foot starts to get pretty small quickly. So how are we rigging the load? How are we attaching to it? Do we need any special lifting devices to get more compact? And so that's everything we should figure out. And so that's what I'm talking about. Headroom is how tight you can get everything from your attachment point to the base of your hook, and then you got your lift and your total reach from attachment point all the way down to your hook saddle, which would be your total length, or your hook at its lowest position would be the reach. Okay, and then your trolley suspension is from the underside of your beam. If you're going to do a trolley suspension, your reach is from underside to the saddle of your hook. Then your lift, how much lift you need to get to the bottom of your hoist, and then from the bottom, or not to the bottom, the lift to where the hook goes to its utmost position, and then from the saddle of the hook to the underside of the beam is your headroom. Okay, and that's what, when you look in catalogs, that's what's specified out, and how you're sizing the hoist. So when you're reading those catalogs, that's what you need. You need to be looking at that stuff and then subtracting out all your rigging equipment to be sure that we're applying it properly. Okay. So we're going to be lifting up 11 feet, and if we lift up 11 feet, we got to come down 11 feet, right? We got to put that load down. So the total hook travel ends up being 22 feet, and they told us they do that 10 times per hour. So the total hook travel per hour is 220 feet, divided by the maximum on time per hour. Is 30 minutes, right? We have that 30-minute motor. So that's our max. We don't want to exceed that duty cycle. So in this case, with the amount of hook travel and everything we're doing, the maximum hoist speed is 7.3 feet per minute. So, or excuse me, the minimum hoist speed is 7.3 feet per minute. So in this case, probably speed's not an issue for us. So a standard 16 feet per minute hoist would work. But you may find that, wow, we need to have a quicker speed hoist to do this. Otherwise, we're going to exceed the duty cycle. So if the hoist is too slow, you could run through that duty cycle quickly. So that, again, that's just to verify that we want to make sure we get a fast enough speed to do that. Or if it is a precision, let's say it's a precision lift, that we're not sizing the hoist to go too slow, and otherwise we're going to have problems. Right? Maybe we size one that's 6 feet per minute. Okay, this is very precise, but given the parameters, it's too slow. And then what's the number of starts and stops? We do it 8 times in an hour, and per cycle, and we do that 10 times per hour. So the total starts per hour is 80. So we're not exceeding that in that case. We're not exceeding that 300. So in conclusion, the weight of the load in any tooling, the physical size of the load, the headroom and obstacles, the lift, the reach, the type of operation it is, the location of the operator, frequency of use, type of suspension, accuracy of load placement, what the application is, power requirements, and what we want for controls, pendant or radio remote. So it's a lot of information. It's not just simply, hey, I need a 5-ton hoist and it's about 20 foot from the floor. Yeah, that's good. Give me a 20-foot reach hoist. on whatever speed, it doesn't matter to me, 16. It's not that simple. And so oftentimes, we'll get calls and say, hey, this hoist is acting up and why. And so as we go through exactly what they're doing, you can find that, hey, this is a misapplied hoist. And you really needed a neck sized up to do this. And then when that hoist gets put in place, everything's fine. They have no problems. They're running for a very long time with very, very few maintenance issues.
Here we got a question that came in.
Sure.
Cable hoists are meant for faster speeds. Is that correct?
Generally, you'll see wire rope hoists at faster speeds, given that the chain hoist, when in the higher capacities, because the chain hoists are going to be multiple reeved, and so we got to overhaul all that chain. So typically, in the larger capacities, you're going to see wire rope. If you go and do side by sides with wire rope models, you'll see some faster speeds once in the wire rope hoist.
Great. Thank you for your questions. Anyone else, feel free to go ahead and type them in and we can take them. But go ahead, Peter.
Okay. So yeah, we're right there anyway, so it was a good time for questions.
All right, they were just starting to roll in. Anyone else, please feel free to type them in while Peter covers the last few slides.
And as you're typing your questions in, we do have some classes coming up. This one actually just sold out recently. These two just sold out recently. But we do have some space in the CMCO wire rope and chain hoist repair technician certification December 2nd through the 6th, December 10th to the 12th in Santa Fe Springs, California. We have some seats available. And then we do have our schedule online up to March of 2014, and we're adding dates. We're going to finish that up and add all our dates for 2014 coming up. So those will be posted as they come. So there are already dates up on our line for various classes. We do have a new course where it's called the CMCO University for our distribution, where it's a sales school where we go over a lot of stuff like this throughout the whole product line and show all the uses and things of that nature. And so you want to contact your CM salesman and ask if and when you can get involved with the CMCO University. And we do have, for more information like this is a recorded session. It gets put on YouTube, but we have a whole series of webinars and videos that we place on YouTube. We're involved with LinkedIn and Peasla does Facebook, and we do a lot of promotions and information on Facebook and Twitter. And then we have a live blog where our trainers do a lot of technical stuff and talk about various aspects of certain questions that come along with rigging or crane operations or hoisting repairs, and we write blogs on them, so it's very informational. So you want to subscribe to those blogs because it'll help you out and give you really good information on what customers are going through. I'll take I'll get emails and I'll turn them into a blog, change the names up and the parameters up, kind of what the application was, to share that with everybody.
Yeah, Peter's right. We have over 120 blog articles now, dating back a few years, covering a whole gamut of topics. We also share industry news, and like you said, a lot of customer question and answers and things about our products. But the product part is not as big as more the information part. So, and if you ever have any questions that you'd like us to feature on the blog, let us know. You'll get an email. You'll get my email address and the follow-up email from this event. And let us know if there are other webinars you'd like to see, if there are other topics that would interest you, because we're always looking for ideas, and we love to run with them. So
yeah, the next webinar, Gisela, is going to be how to inspect chain in hoist, which is a lot different than the inspection from rigging chain. So if you've never done any inspections on hoist chain, we're going to cover how you inspect and what to look for and how you maintain hoist chain.
Yes, and that will be on November 19th. Just be a week before the holidays, and I'm going to send you information in the registration link in our follow-up email should you be interested. So at this point, I don't see any more questions, so we'd like to thank you all for coming and for participating and attending today. As I said, we'll send you a link to the recording, and happy Halloween, everyone.
Thank you.